y is less than or equal to 3/2 x plus 1. So I'm going to graph this the same way I would graph y equals 3/2 x plus 1. So I'm going to start at the 1. I'm going to go up 3 and over 2 throughout my graph. This is going to be a solid line because it says less than or equal to. I'm going to break out my ruler. And I'm going to graph my line. Let me zoom back in. Now, 0, 0 is not located directly on my line, so I can use this point to determine if 0, 0 is a solution. So I'm going to say, is 0 less than or equal to 3/2 times 0 plus 1? So is 0 less than or equal to 1? Yes, that's a true statement. So I shade the region of the graph that contains 0, 0. So that would be everything on this side of my line. So, let's see. All of this would be considered part of the solution. I'm going to do the same thing for this equation. I'm going to graph y equals -1/2 x minus 3. So I'm going to start at the -3. And I'm going to go down 1 and over 2 throughout my graph. But this is going to be a dashed line because it says, I'm sorry, this is going to also be a solid line because it says greater than or equal to. So I'm going to break out my ruler. I'm going to line up my points. Solid line. And I'm going to notice that 0, 0 is not located on this line either, so I can use it as a point. So I'm going to say, is 0 greater than or equal to -1/2 times 0 minus 3? Is 0 greater than or equal to -3? Yes, that's a true statement. So I'm going to shade the region of the graph that contains 0, 0. I'm going to pick a different color. So that would be everything above the line. And if you notice, all of this is considered dually shaded or double shaded, so it would be considered part of the solution. So this region of the graph, which is shaded twice, is the solution to the inequality.